And welcome to the YouTube channel D Creations Resources. We are looking at different concepts as well as devices in the series Tell Me What. So today let us know about OpAmp. Now OpAmp is a short form for an operational amplifier. So as the name indicates, there are two words basically, operational and amplifier. So operational comes from the fact that an OpAmp can be used to perform mathematical operations, be it addition, subtraction, integration, differentiation, and so on and so forth. While the other word, amplifier, of course, comes from the fact that increase in the voltage is possible, which is known as amplification. So you can say that an OpAmp is a voltage amplifying device which is designed to be used with external feedback components. And these components could be resistors, capacitors, etc. And it's a high gain amplifier with a differential input and a single-ended output. So there are certain characteristics of this OpAmp which have already been highlighted, that it can be used for mathematical operations, that it amplifies voltage, that it has a feedback mechanism between its input and output terminals, and it has a very high gain. So these are one of the most widely used electronic devices because they can be used for several things. Now, there are certain parameters of OpAmp. Basically, differential amplifier. That means the circuit that amplifies the difference between two signals is important part of an OpAmp. And so when I say differential amplifier, you can say that if V out is the output, then V output is equal to gain, that is A, into V plus minus V minus, where basically V plus and V minus denote the two input terminals. Now, there's open loop gain. The idea, the name itself tells you open loop. So basically it's a gain without positive or negative feedback. And an ideal OpAmp has infinite open loop gain, but for a real OpAmp, the value will range from 20,000 to 2 lakh ohms and so on and so forth. Now there is input impedance. As the name suggests, input impedance. So it will be ratio of input voltage to input current. Again, for an ideal OpAmp, it is infinite. And when you say that is infinite, basically any current flowing from the source to the amplifiers is prevented. Now, like input impedance, there is also output impedance. And for ideal OpAmp, it is assumed to be 0. And this impedance is in series with the load. So, since it is 0, the output available for the load is more. Now, for an ideal operational amplifier, there is infinite bandwidth. That means it can amplify any frequency. Of course, for a real OpAmp, that is going to be different, and there is going to be something called as gain bandwidth product, and it's equal to the frequency where the amplifier's gain becomes unity, etc. Now, ideally, if the voltage difference between the inverting and the non-inverting input is 0, the output, which is multiplication of gain and this difference between these two, also has to be 0. But in reality, there is some voltage which is seen, and it's called offset voltage. Now, as mentioned earlier, in linear circuits, OpAmp has several applications, like it can perform mathematical operations such as addition, subtraction, then at that time it is called adder, subtractor, etc. respectively. It can also be used for voltage to current conversion and vice versa. So it's a very versatile device.